Hello everyone. In this video we will talk about exploratory data analysis. So basically there are four characteristics of a distribution, which are central tendency, dispersion, skewness and kurtosis. We will talk about each one of it one by one. What is central tendency? Central tendency is the quality of a data set to cluster around some value. This is known as the central value. For example, if we have a sample of 300 women to create awareness about cancer screening and we are getting an average of 55 years, then this number is nothing but the central value. There are many measures of central tendency. Here we will talk about mean, median and mode. Mean, which is also known as arithmetic mean, is a typical average. It is most commonly used measure of central tendency. It serves as a balance point and it is most important value when data is scattered without a typical pattern. So how we can calculate arithmetic mean? The formula is very simple. This is sum of all observations divided by total number of observations. So like here, if we have suppose nitrogen oxide concentration values and we wanted to take its average, so we have to simply add all the values and divide by total number of observations. Here the total observations are 4, so we will divide it by 4. So here in this case our interpretation will be on the basis of given data, average nitrogen oxide concentration is 59.75 units. Now quickly review the merits and demerits of arithmetic mean. Okay, so it's unique, it's easy to calculate and understand. If we multiply all the values by a constant, then mean is also multiplied by the same constant. So for example, here in the previous example, NO2 concentration in current year is 1.2 times as compared to the last year. Then simply we can take the old average and multiply it by 1.2. We need not to recalculate. Okay, we can simply use one arithmetic operation and calculate the new average. Similarly, if a constant is summed to each value, the mean is summed in that constant also. So again in the previous example of nitrogen oxide concentration, if NO2 in current years increased by 10 units, then we simply need to add 10 and we will get a new result. It is least affected by sampling fluctuations. So suppose from a bigger population, if we are taking multiple samples which we can take, and every time because our sample is different, we will get a different mean. Okay, but if we are calculating mean, then there will be very less variation in mean values we are getting from different samples. So this is what we mean by it is least affected by sampling fluctuations. Its demerit is when we have extreme values. Extreme means too big or too small values as compared to the other data points. Then mean may not be a representative. For example, suppose if we have this data 1, 2, 3, 4, 3, 2 and 100. Okay, so here if we calculate the mean of the entire data set, all 7 data points, then it is 16.42. But but you can see that 100 is a too big value. So if we ignore 100 and take a mean of only 6 values, then this is 2.5. Now obviously if we look at the data set, then 2.5 is somehow in between of these data points. Okay, so 2.5 is a better central value as compared to 16.42 in this data set. So this is one of the example where you can feel that mean is much affected by outliers. So in case of outliers, we should not use mean. Its next demerit is it cannot be calculated in case of open-ended intervals. Open-ended means when one of the limit of a particular interval is not known, like here less than 20 years. So here we don't know the lower limit. The upper limit is 20 years, but what is the lower limit, which we don't know. So this is the example of open-ended interval. Similarly, more than 65 years. So here 65 years is the lower limit, but we don't know about the upper limit. So in these scenarios, we cannot calculate the mean. Next is, it cannot be used if we are dealing with qualitative data. Yes. So we must have data on interval or ratio scale to calculate the mean. We cannot calculate mean when we are dealing with qualitative characteristics. The next measure of central tendency is median. The median is the middle observation in a set of observations that have been ranked in numerical order. So when we have to calculate median, we have to first arrange our data set into ascending or descending order, and then we have to pick up the central value. That will be the median. So if we have odd number of observations, like here we have 7 observations, 7 is an odd number. So in that case, here the blue box indicate the raw data, and in a green box we arrange it in ascending order, and then we pick up the middle term. So 20 will be the median for this data set. If you want to use formula, then its formula is n plus 1 by 2th term. When we have even number of observations, then what to do? Because in case of even number of observations, there will be no single middle term. There will be 2 middle terms. So in that case, we have to take average of 2 middle terms. Like here, again in blue box, we have a raw data and we arrange it in ascending order in a green box. And now you can see that there is no single middle term. We have 20 and 21, that means third and fourth term, 2 terms as a middle term for this data. So we have to take average of these 2 terms. So 20.5 will be the median for this data set. The formula for median in case of even number of observations is average of n by 2th term and n by 2 plus 1th term. What are the characteristics of median? It is easy to understand and calculate. It is not affected by extreme values. Like here, again, if we pick up the same data set we use in case of mean. Okay, so in this data set, the mean value is 16.42 for the first data set 1, and median is 3. And for data set 2, the mean is 2.5 and median is 3. Okay, so what is the difference between data set 1 and data set 2? In data set 2, there is no outlier. So in this case, mean is a better representative. But in case of data set 1, there is one value which is too big as compared to other data points. So in this case, the mean is 16.42, while 16.42 is nowhere in the data set 1, right? Even no value is close to 16.42 in data set 1. So in this case, median is a better representative. So as I told you earlier, when we have outliers, we should not use mean as a measure of central tendency. Then which measure we should use? So its answer is, we should use median as a measure of central tendency when we have outliers. Its next characteristic is, it can be calculated for distributions having open-end classes. Okay, so when we have open-ended intervals, then also we can calculate median. Then it can be calculated in case of qualitative data arranged in ascending or descending order. So that means if we have ordinal scale data, then also we can calculate median. We cannot calculate mean for ordinal data, but we can calculate median. Its demerit is, in case of even number of cases, median cannot be calculated exactly. Yes, we saw it, because when we had 6 number of observations, then we have to take average of 2 middle terms. So this is its demerit. And its next demerit is it is not based upon all the observations. Yes, so it is not based upon all the observations. We have to just look at the middle term after arranging the data in ascending order. Then it is affected much by sampling fluctuations. So just like mean is least affected by sampling fluctuations, median is much affected by sampling fluctuations. Okay, so the next measure is mode. The mode is usually defined as the most frequent value. We can consider its application as if we have a question like which shoe size sell most, which method of payment is most preferred by the customers, or in environmental science we can say which state has most contaminated sites. So what are the steps for computation of mode? We have to determine all distinct values of a characteristic under study, then count frequency for each distinct value of that characteristic, and the most frequent value is the mode. Like here we can see that the most preferred method is debit card because its frequency is maximum. Similarly here the shoe size sale most is shoe size 5 because its frequency is maximum, that is 50. What are the characteristics of mode? It is easy to understand and calculate. It can be calculated in case of categorical data. It can be calculated in case of open-ended intervals. Its demerit is it can be more than one. So it might possible that we have the same highest frequency for 2 data points or more than 2 data points. So in this case, we have more than one mode. If we have two highest values, then our data will be bimodal. If we have more than two highest values, then our data will be multimodal. And it is not based upon all the observations. Sometimes mode cannot exist. Because suppose if all the values occurs just once or the equal number of times, then there will be no mode. The next characteristic of a frequency distribution is dispersion. What it is? It measures the extent of variation in a data set. Like here we have two data sets, data set 1 and 2. Both have 10 observations. In data set 1, the minimum observation is 20 and maximum is 25. While in data set 2, the minimum observation is 0 and maximum is 100. Okay, so obviously if we are just looking at the data, we can make out that data set 2 have more variation as compared to data set 1. Then what is the importance of dispersion? Why it is important to report dispersion along with location? Because it gives us better insight. Like here, for both data set 1 and 2, the mean value is 3, but dispersion is different. Like in data set 1, the values are only 1 unit apart, while in data set 2, the values are 2 units apart. So variation is more in dataset 2 as compared to dataset 1, although they both have the same mean value of 3. So location plus dispersion is equal to better insight. Same is here. Here we have plotted the three distributions which are indicated by blue, red and green colors. Both have the same central value, but they have a different dispersion. You can see that the tail of the distributions are different for all three curves. So it is very important to report dispersion along with location. Dispersion helps us to understand distribution of data. It gives better insight about data. It forms basis of statistical theory. Now what are the measures of dispersion? There are two kinds of measures, absolute and relative. As an absolute measure, we have range, quartile deviation, interquartile range, mean deviation, variance and standard deviation. While as a relative measure of dispersion, we have coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation, and coefficient of variation. So let's discuss some of them one by one. The first absolute measure is range. What is range? This is the simplest form of dispersion, and we can calculate it by simply do a one-step calculation, which is maximum minus minimum. Okay, so just like here, we have a data set of time to get ready in the morning for 10 days. Okay, so the minimum value is 29 and the maximum value is 52. So we simply subtract 29 from 52 and we will get the range, which is 23 minutes. Here is second example. Here we have age of 20 students in a class. So here the largest value is 24 and smallest is 20. So range will be 24 minus 20, that is 4 years. What is the limitation of range? It does not take into account how the values are distributed between the smallest and the largest value. Very true. So we are not changing the smallest and the largest value, and everything in between will change. It will not affect my range because it is not based upon the all observations. This is the limitation of range. The second one is interquartile range. Interquartile range is also very straightforward. We simply have a formula of third quartile minus first quartile. So IQR is nothing but third quartile minus first quartile. Now you might thinking about the quartiles. What is first quartile and the third quartile? So if we have total data and we divide it into 4 equal parts. Okay, so every segment will carry 25%, right? So first quartile is a point below which 25% data exists. Second quartile, which is also known as median, below which 50% data exists and above which 50% data exists. And third quartile is a point below which 75% data exists and above which only 25% data exists. The next measure of dispersion is variance and standard deviation. Variance is a measure of variation that accounts for how all the values are distributed in a data set. It conveys how widely or tightly the observations are distributed from the center. Average variation of data points around center value. Variance and standard deviation is widely reported along with mean. So when we are calculating variance, we need to take a square of the unit also. Like if we are talking about weight, then for calculating the variance of a weight, we will be kg square. We are measuring the weight in kg, kilograms. Then variance will be in kilogram square. So it will be little difficult to interpret the variation in terms of square of the unit. For that, in standard deviation, we are taking the square root of the variance. So standard deviation is nothing but the square root of the variance. When we are doing this, we are again getting back to our original unit. For example, here kilograms. Okay, so that is why we prefer standard deviation over variance in many situations. In relative measures, we frequently use coefficient of variation. What is coefficient of variation? This is standard deviation divided by mean multiplied by 100. And this is suggested by Professor Carl Pearson. This tells us percentage variation in mean, standard deviation being considered as the total variation in the mean. Next characteristic of a frequency distribution is skewness. So skewness can be of two types. So see, if our distribution looks like a bell-shaped curve, then it's a normal distribution. If it doesn't look like a bell-shaped curve, that means it is skewed to the right or to the left, then it means our data is skewed. Okay, so this skewness can be of two types, positively skewed and negatively skewed. In case of positively skewed distribution, it is a long tail in a positive direction. So that means this is skewed to the right. In case of positively skewed data, Mean is always greater than median, is always greater than mode. In a negatively skewed data, mean is always less than median, is always less than mode. And this is skewed to the left. It is a long tail in a negative direction. The next characteristic of a frequency distribution is kurtosis. Kurtosis measures the peakness of the curve of the distribution. It compares the shape of the peak to the shape of the peak of a bell-shaped normal distribution. So here in this graph, green color is a normal distribution, which is also known as mesocurtic. If peakness of our data is more than this normal distribution, then this is leptocurtic. Otherwise, if the peakness is less than the normal distribution, then this is platycurtic. Here are some good references to go through this topic. And if you have any queries, please feel free to connect. I will be very happy to answer all your queries. Thank you, everyone.